FAQs math class today. Still on coordinate geometry, we've been discussing. Follow my teachings, my previous classes on coordinate geometry. So this point we are now. Distance between 2 points on a line. Distance between 2 points on a line. Supposing we have a line, a straight line, with respect to the two mutually perpendicular axes. Supposing we have this straight line, and we want to find the distance between 2 points. Distance between 2 points, allowing the 2 points to be here, P and Q. Suppose P has coordinates x1, y1, and Q has coordinates x2, y2. We want to find the distance between here and here. And you calculate the distance between yourself and the nearest point on the wall, where we are. In that place we are now. We want to do it geometrically. The distance between P and Q on this line. That reminds us about the slope, determining the slope of a straight line, wherein we make the right angle triangle with the reference line or point. Now, with this slope, we know that the distance from here to here is given by y2 minus y1. y2 is this point where we started as slope, and the y1 is this point where we started, and this point we ended with y1. This point is the x1, and this point is the x2. So the distance from here to here is x2 minus x1. So to find the distance here, knowing that this is a right angle triangle, we use Pythagoras. Thus, distance PQ, distance PQ is equal to, by applying Pythagoras, bracket x2 minus x1 squared plus y2 minus y1 squared. So this is the distance between this and this. Take note of this relation. Before we do calculation, take the formula. The distance between 2 points, PQ on a straight line, is given by square root of x2 minus x1 plus, in parentheses again, y2 minus y1. Furthermore, distance between a point and a line. For instance, I'm a point. I want to approach the road here, so that I can pick a possible automobile. So the distance, the road there is a line. The distance between a line and a point. The distance. Look at the point here. Between a point and a line is given by amending this relationship. We have the distance between the point and the line as ax plus bx plus minus c divided by square root of a squared plus b squared plus we put plus and minus. This is the distance between a line and a point. Having noted this, we now delve into solve examples, calculations. at this. Calculate the distance between these 2 points. How do we get the distance between them? We quickly write distance PQ is equal to square root of x2 minus x1 square plus y2 minus y1 square. That gives us square root of bracket x2. Look at x2 minus 3 minus x1 is this. You square it plus y2. Look at y2, 1 minus y1. Look at it. Square it. That gives us minus 4 squared plus minus 1 squared, which gives 16 plus 1. And that gives square root of 17. This is the distance between the points. That's how to find the distance between the points. Wow, that's very interesting. Yeah. Question 2. Calculate the distance between the point A and the line 2x plus 3y plus 6 equal to 0. This is the point and the line. We want to find the distance between them. Recall that the distance between the point and the line is given by the equal plus and minus ax plus b y plus c divided by square root of a squared plus b squared. And that gives us a, which is what? The coefficient of that is 3. Coefficient of y, coefficient of x1, which is 2. Bracket here you have x, you put 1 plus b, which is 3. You write 3 there plus c, which is 6, divided by square root of what? Square root of 2 square plus 3 square. That gives us 2 into this is 2. 3 here is 9 plus 6 divided by square root of 4 plus 9. Check it out. And that gives us 17 divided by square root of 13. 17 divided by the square root of 13, 3.75. And then you can finish it. 17 divided by 3.75. That's how to find the distance between a point and a line. Distance between a point and a line. Now we take on another example. Given a triangle A, B, C. Describe by the coordinates. Describe by the coordinates. Okay. And then C.
I'm the cameraman.
Find the area of this triangle. Look at this triangle. We want to find the area. The triangle can be shown diagrammatically. The triangle can be shown diagrammatically. A has a coordinate 3, 5. B has a coordinate 1, 0. And C has a coordinate. C is on the coordinate 6, 0. How do we find the area of this triangle? Before we find the area of the triangle, we'll get the length of these lines, because these coordinates describe the points here, not only the length. Now, I'm going to push it up to a point, and that will allow you as a quick test to finish it up. For you to find the area of this triangle, you find the length of the line. How do you find the length of the line? AB. You use the formula, distance between them. So you now find the distance AB. Distance AB. AB is equal to, using the formula. So AB will be what? A to B, line A to B will be x2 minus x1, which is 1 minus 3 squared plus y2 minus y1, 0 minus 5 squared. That gives us square root of minus 2 squared plus minus 5 squared, which gives square root of 4 plus 25, giving us square root of 29. You finish this one off with your device, your calculator. Distance, again, A to C, AC, is equal to square root of x2 minus x1, which is 6 minus 3 squared plus y2, which is 0 minus 5 squared. You get it now? You finish it off, you get square root of 3 squared plus minus 5 squared. Gives you square root of 9 plus 25. Gives you square root of what? 34. And finally, distance B to C. Distance BC, using the same method. X2, which is 6 minus x11 squared plus y2, which is 0 minus 0 squared, gives us square root of 5 squared plus 0 squared, gives us square root of 25. We now have these numbers to work with to find the area of the triangle. A triangle whose three sides are now known will be calculated by the formula area equal to square root of s bracket s minus a, s minus b, s minus c, called the hero's formula. Where a, b, and c are the three sides, but s is known as semi-area, and it is computed differently or separately with the formula a plus b plus c divided by 2. Whatever result you get from here, you plug it into this and get the area of the triangle. I'm waiting for you to produce the result before I display mine. Thank you.